Welcome to this Getting Started with a Keyless hands-on video. This video demonstrates how to inject secrets into Kubernetes at runtime. There are a few reasons to use an external secrets management platform for managing Kubernetes secrets. Firstly, native Kubernetes secrets are merely base 64 encoded and easily decoded by anyone with access, whereas external managers enforce true encryption at rest using robust KMS or HSM systems. This ensures your sensitive data is safe from exposure, even if your underlying cluster database is compromised. Second, Kubernetes RBAC is not fine-grained, typically forcing an all-or-nothing approach, where granting access to one secret grants access to every secret within that namespace. It also lacks the ability to enforce the path-level policies, time-bound permissions, and multi-factor conditions that dedicated secret managers provide. Third, Kubernetes has no built-in auto-rotation mechanism, meaning leaked credentials require risky manual intervention to update. External secret managers automate the versioning, tracking, and rotation of keys, and can even generate ephemeral dynamic credentials. Finally, Kubernetes has no method for managing all your credentials in one place for multiple Kubernetes clusters, cloud virtual machines, and serverless workloads simultaneously. External secret managers offer a single source of truth. A keyless Kubernetes Secrets Injector enables Kubernetes applications and workloads to inject static, rotated, and dynamic secrets, as well as certificates and externally managed secrets, into pods sourced from an keyless user account. Before the application starts, the injector deploys an init container to fetch and inject secrets into the pod at startup, after which the init container shuts down. This can be used for static, dynamic, and rotated secrets, as well as certificates and external secrets. In addition to that, we offer another option that uses a sidecar container deployed alongside the init container, which enables updating secrets at specific intervals. The sidecar container continuously monitors changes to secrets inside a keyless, so if the value for a static secret, rotated secret, certificate, or external secret changes, the sidecar will fetch the new version and update it automatically. In this demo, we will start on the keyless side. First, we will create an access role for our Kubernetes authentication method, which we created in a previous video, and give it enough permissions to fetch secrets, and we will also create our static secret to be injected into Kubernetes. We will then move to the user's local environment, where we will use the keyless CLI to download, edit, and deploy the Kubernetes Secret Injector. Lastly, we will move to the Kubernetes side, where we will demonstrate how to inject the secret into the container at runtime, and then a second example with an additional sidecar container, which will check for changes in the secret value every 30 seconds, and we will see the change take place. Before continuing, make sure you have the following: a Kubernetes cluster running Kubernetes 1.16 or later, Helm installed on your machine, a Kubernetes authentication method in a keyless, which we covered in a previous video, the Kubernetes mutating admission webhook admission controllers enabled, which should be on by default. Let's get into the demo. Starting out, we can see our Kubernetes authentication method set up. We can also see that it's configured in our gateway. We need to create a new role for the auth method, which we will call Kate's role. Associate the myKatesAuth method, and give it read and list permissions on items in the root path. Best practice is to associate auth methods with a role with tighter permissions. This is meant for demo purposes only. Next, we will create our static secret in the console. Let's call it Kate's Injector Secret and give it a value. We will now move to the CLI in order to install the keyless Kubernetes Injector plugin. From the terminal, make sure to add the keyless Helm repo and update your Helm repos with these commands. Then, download the injector values Helm chart using the Helm show values command, and we will call our file injector.values.yaml. Now we edit the values file. We are using VI for this. Go down to the env section and edit the URL to vault.achilles.io. Set the access type to Kate's, Set the access ID to your Kubernetes auth method access ID. Add your gateway URL with /API/v1 at the end. And put in your Kubernetes conf name, which for us is KatesConf. Make sure to save the file and then exit the editor. You can see the Kubernetes conf name here. Next, make sure you are connected to your cluster and run the kubectl create namespace command to create a new namespace, which we will call Kubernetes Secret Injection, and then label it with the kubectl label command. Then we install the injector values Helm chart with the Helm install command. After about a minute, we run the kubectl get all command to see the deployment, and once it shows everything ready, we can move on. We are now going to inject secrets into our pods. Let's start by creating a new YAML file with a simple app deployment, which creates a pod with an init container that holds the mySecret variable, which will fetch our secret value. Run kubectl apply, and then we can check the logs of the app, and we see our secret value was injected. Now we will show a sidecar example. We start by creating another YAML file with a simple app deployment, but this time we have annotations that inject the secret as a JSON file into the pod file system, enable the sidecar, and give it the location to inject the file. Make our sidecar refresh interval 30 seconds, and we will retrieve the last two versions of the secret, versions 3 and 4. Lastly, we have the init container running a command that checks the latest values in the JSON file. Save that and run the kubectl apply command to deploy the pod with both init and sidecar containers. Checking the logs, we see the last two secret values. But now we will go back to the console, update the secret value, and save that. Then we will wait a bit for the next refresh interval and go back to the terminal and run our command again. And we now see that we have a new version 5, which is updated with the new value, as the sidecar automatically retrieved the latest secret value at its last check. Now you know more about how to utilize the Kubernetes Secret Injector. More information can be found in our docs. Thanks for watching.